Yes, last time we looked at angles. Yes, angles, and we said that angles is a measure of rotation. Yes. Now today we are going to look at parallel lines. Parallel lines. Now I want to show you lines. I have two lines here, this and this. Now if I continue to extend this line and also this one, they will never meet at any point. Yes, if I continue to extend this line, these two lines like this, so you will see they can never meet at any point. So because of that, I will say that these two lines are parallel. Yes, so parallel lines are straight lines that will never meet. Two straight lines that will never meet is referred to as what? Parallel lines. Okay. Now, like this line, line PQ and line ROS, they are parallel lines because they can never meet as I continue to extend them. Now, this line that called these parallel lines, this line is called transversal. It's called transversal line. So transversal line is a line, is a straight line that cut two or more straight lines. So this particular line that cut these two lines is called transversal line. So this line is called a transversal line. So this is a transversal line. Okay, it's a transversal line. Now, in a transversal line or in parallel lines, there are angles that are, made there. We have the light of the angle we call alternate angles. We have the one we call corresponding angles. We have vertically opposite angles. We have adjacent angles. We have interior opposite angles. These are the kind of angles we can see in parallel lines that have a transversal line. Okay. Now let's look at the first one, alternate angles. How do we know, or how do we recognize alternate angles in parallel lines with transversal line? Okay, we normally use this kind of shape, Z shape. It's either it looks like this or like this, so somehow like Z. So this is the normal Z we have in our alphabet. This thing is also a kind of Z shape. So any time we trace out lines and the lines look like this shape here, then the angles now subtend here is referred to as alternate angles. So let's look at this, our parallel lines with transversal line. Okay, in this place, let's try to trace out Z from this place. Let's try to trace out Z from this place, okay? So I will start from here. On getting to this place, I will come down, then move this way. So look at where I am going to trace now. Let me use this red pen. So this place like this, then come down, then go this way. So from here, this shape is like Z, which is what I have here. Then I will now look at where I can make where angles are formed, because after tracing this line like this, angle is not formed here and angle is not formed here. The only place angle is formed is here and here. So those places that angle is formed when I trace my Z shape is called alternate angles. So like this place from here now, see, if I trace this thing out, where I can have angles here is C and F. So I have C here, then I have F here. It means that C is equal to F, and we say that alternate angles are equal. So alternate angles are equal. Alternate angles are equal. Anytime we trace out Z, and the angles we can see in that shape is referred to as alternates. So, and alternate angles are equal. Okay. Now let me trace out another Z from this diagram. In this place, I have something like this. Look at this one. From here, I am going this way. then I will go like this. So this is another Z shape I have here. Like this, go up, go that side. So from here, I will see this kind of shape here. Now look at where I have angles here. Because angle is not formed here, then angle is also formed here. So because this shape is Z shape, then these two angles are alternate to each other. So we say that they are equal. So this angle and this angle, this angle and this angle, they are equal. So let's come to this place. What I have here is E. In this place I have E. Then what I have here is D. I have here D. So that means that D is equal to E is equal to D. And the reason is what? Alternate angles, not corresponding. Alternate angles are equal. Alternate. So alternate angles are equal. Now let's go to the next one, corresponding angles. Now corresponding angles, we normally use something like F shape. We normally use F shape when our parallel lines, when there are two, when we have two parallel lines. But when we have three parallel lines, then we can have something like E shape. But then before I continue with corresponding angle, there is something I want to show you. Before we refer to or we call any angle here alternate, we must see this sign. So this arm of the Z must have this sign. This arrow must be there, showing that these two lines are parallel. If these two lines are not parallel and we have something like Z, we cannot call it alternate angles. Yes, look at what I mean. If I have something like this, you see, if you watch very well, and I just leave it like this without putting any sign like this here, this kind of sign. If there is no arrow sign here and no arrow sign here, then these angles, they will not be equal. Alpha will not be equal to theta, because I cannot call this relationship alternate. I cannot call it alternate because these lines are not parallel. Please take note of that. These lines are not parallel. So before I will say that alpha is equal to theta, which is alternate angles, this line must be parallel to this one. Please take note of that. Very, very important. This line must be parallel to this line. Then on having this transversal line, then I can now say that alpha is now equal to theta, which is alternate angles. Okay, and the same thing is applicable to the one we want to look at now. Okay, which is corresponding angles. Now in corresponding angles, like I said earlier, we normally use something like F shape, like this one or this one, to showcase to show this corresponding angle. And this arm of this F must be parallel lines. There must be parallel lines. Then it is like F if our parallel lines here are only two. But if they are three, like this one, let me add one more. If they are three like this, then our shape will be looking at will not be something like E. Will not be like E. So, and that is how we normally trace out our corresponding angles. Okay, so now let's come to this place and trace out angles that are corresponding. So I will try to trace out something like F. So let me start this way. From here, I will come down. Okay, then I will now move this way. So I am now having something like this, then coming down. So if I bring it out, I have it here, this one, So this one with blue ink before I add this one. So I have it here. Look at it here. And this way. So all the angles formed there, they are corresponding angles. So if we go to this place, in this place we have D. So there is D here. In this place we have H. So that is H here. So that means that H is equal to D, and the reason is corresponding angles. Yes, they are equal to each other, and the reason is corresponding angles. Okay, now if I have, let me put an angle here, angle I in this place. So I am looking at this line now. Now if I have angle I here, that means that this place will now be angle I. Okay, so that means that H is equal to, okay, let me say I is equal to H, and H is equal to D, and the same reason, corresponding angles, they are corresponding to each other. Okay, fine. Now let me come to this side. If I trace this F this way, like this, if I trace F like this, so be careful, this way, and come down. So I will now have this kind of shape. Then if I trace the three of them, look at this first line, second line, third line, then with this one now, and I will now have these new lines, or this new shape that I have here now. Okay, now let's go back to this place. So having traced this thing, now this angle from here is here. See? Then look at this angle from here is G. And if I put J here, then this angle from here is J. So that means that J is equal to G and is equal to C. And the reason is corresponding angles. Okay? That is the reason. Now, look at this shape. Actually, this shape looks like a F, but because we don't have parallel lines here, then we cannot say that this angle and this angle are corresponding. We cannot say that. It is not corresponding. Why? Because these lines are not parallel. These lines are not parallel. These lines are not parallel. It is only when they are parallel, if I put this arrow showing that they are parallel, then I can now say that this angle is equal to this angle. So now A is equal to B, corresponding angle. Okay, now look at another one. Okay, in this one we have this angle is corresponding to this one, and it's also corresponding to this one. Now, because we are taking the angle this side, what if I have an angle this side? Yes, if I have an angle this side, then this side will still be corresponding to this one and correspond to this one. Okay, so even in this place now, if I have angle at the top here, so those ones on the top will be corresponding to the other top side. Okay, so that is just that. Here, the angle here is corresponding to the angle here, and this one is corresponding to the angle here. Okay, so but the main thing is just to trace out your shape, either F shape or E shape. Now the next one we have here is vertically opposite angle. Now we normally use X like this to trace out vertically opposite angle. Now in this place, let's try to trace out X. So look at, just move, make sure that this line is straight. So this is a straight line, and we have another straight line that intersects here. So look at this. If you watch very well, this shape here now, this shape you see here looks like X. Looks like X. Another place we can have it is this place. Look at it here and here. So it actually looks like X. So when we trace out straight lines, that looks like X here, then the angle here and the angle here is referred to as vertically opposite angle. So in this place, this angle is equal to this angle, and the reason is vertically opposite angles are equal, and this angle is equal to this angle, and the reason is what? Vertically opposite angles are what? Equal. Okay, now let's look at this shape here. This, we have another one here. Now can we trace out vertically opposite angles? Now we normally make use of the straight lines there. So if you watch very well, this line is a straight line. Okay, so we can even draw it out this way. Then another straight line we have here is this one. This one is straight line. Okay, so let's draw it out. Okay, now look at this one. This line is not straight, so this one is a different line from this one. So this one reach here and stop, so that means this is another line altogether. So we cannot trace out this line because we normally trace out straight lines. Okay, so this is the only one line we can trace out from this place to make X. That means that the angle here, so from this diagram, the angle here is equal to the angle here. So that is what we have here. And from here, the angle, look at this angle now, or this angle now, from here to here, which is here, is equal to all the angle from here to here. It's equal to all the angle from here to here. So sometimes in a mass, if they give us something like 20, okay, let me say 24 here, 24 degree, and now in this place they give us 154, for instance, and they ask us to find the value of this angle that's only from here to here. Maybe they call it alpha. It means that since from here to here is the same as from here to here, it just means that alpha plus 24 is equal to 154. Okay, and the reason is what? Vertically opposite angles. So we can now find alpha by crossing this one over here. So we now have 154 minus 24. Okay, so 4 minus 4 is 0, and 5 minus 2 is 3, and we now bring down 1. Okay, so our alpha will now be equal to 130 degree. Okay, so that is just the way to solve distance. Okay, now the next one we have here is adjacent angles. Yes, adjacent angles is just like angles on a straight line. We normally see it like angles on a straight line. So like now, if we have lines like this, if we trace out something like this, something like T, we normally take T shape. So something like this, whether it is standing this way or upside down. So if we have something like this, we call it adjacent angles. Okay, so any angle here is adjacent to any angle here. Any angle here is adjacent to any angle here, and the adjacent angles sum up to 180 degree. Okay, so let's look at our diagram. Okay, in this place now, look at the first straight line. So if I trace out T from here, look at this thing, just trace this line and stop here. If you trace this line and just stop here, look at your base straight line. So look at the base straight line. PQ is the base straight line because it's a parallel line. Then we have this line, the one that starts from X to this place, but we will not allow this line to cross line PQ, or even if I allow it to cross. So let's take it anyway. This line from X, look at it here. So from here, we now have adjacent angles here, and also down down here, we have another adjacent angles here. That is, if we're looking at this way, so that means that A is adjacent to B, and also C is adjacent to D. Or you can follow this way. B is adjacent to D, and A is adjacent to what? To C. Okay. So if we have alpha here, angle alpha, and angle theta here, then these two angles are adjacent to each other, and we say that adjacent angles sum up to 180 degrees. So alpha plus theta is equal to 180 degrees. So you can say adjacent angles sum up to 180 degrees, or you can say angles on a straight line is equal to 180 degrees. So these are the two reasons you can give in this place. So this is called adjacent angles, or you can say that these two angles are on a straight line. Okay. Now, even if I continue this line, okay, let me do it here. If I extend this line across this way, then I have angle A here, then angle B here, angle X here, then angle Y here. Then I can say that B is adjacent to Y, because now I am taking this very line as the baseline. So this line, these two angles are adjacent to each other. Or I can take this one as baseline, then A and B will be adjacent to each other. Or I can still take this one as baseline, then A and X will be adjacent to each other. So that means that A plus B is equal to 180 degree, and B plus Y is equal to 180 degree, and Y plus X is equal to 180 degree, and also X plus A is equal to 180 degree. Yes, the reason is just what? Adjacent to what? Angles. All these angles, they are adjacent. A and B, they are adjacent to each other. X and Y, they are adjacent to each other. A and B, they are adjacent to each other. Okay, fine. Okay, now we are going to go over to the last one we have here. Now this one is called interior opposite angles. Okay, now we normally use this kind of shape to notice it. Okay, something like this, something like this. And these two arms, they must be parallel to each other. And this is now the transversal line. So you must have, these two lines must be parallel, not just any line. Like if we have something like this, no, this is not, as far as this line is not parallel, this one is wrong. Okay, but in this place, this is where we can have what we call opposite interior angles. Now this is the interior angles here, this place. So any angle here, angle A and angle B, sum up to 180 degree. So A plus B is equal to 180 degree. That means opposite interior angles are what? Supplementary, or you can say that they sum up to 180 degree. Opposite interior angles are what? Supplementary. Okay, it can also be like this. Just trace out that kind of shape. The shape like a U somehow. It's like U a little bit. So when you trace it out, you can see. But make sure that these lines, they are parallel. These arms, they are parallel. Okay. So now, if I have arrow here and Q, then this and this sum up to 180 degree. Okay. Now let's look at our diagram. Okay, in this place, let's try to trace out opposite interior angles. Now look at this place. From here, I can go down, go like this. So you see that shape. So from this place now, if I trace this thing out this way, look at it here. So if I trace it out this way, this place is D, so here is D, and this place is F, here is F. So trace very well, don't make mistake. So look at it here. Okay, this is F. It means that D plus F is equal to 180 degree. So D plus F is equal to 180 degree, and the reason is what? Opposite interior angles are what? Supplementary. Then if I trace it this way, from here this way, look at this way now, this way, then I have C and E. That is if I am following this way now, look at it, will not be like this. So look at it here. So I have C here, this place is C, then I have E, this place is E. Then I can now say that C plus E is equal to 180 degree. Then my reason is what? Opposite interior angles are what? Supplementary, or they sum up to 180 degree. Okay,